Alright, geometry, we're going to start this in Unit 1-2, points, lines, and planes. A point is a location, and it has no size, and you represent it by a dot, and you name it by a capital letter usually, like point A. A line is a straight path in opposite directions, has no thickness, and it has no end, and has infinitely many points on it. And you name a line by any 2 points on the line. This would be line AB, written this way, or line BA, because it goes either way. Notice how the line above those letters has arrows on either end. That's important. Or you could name it by a single lowercase letter. In this case, it is line L, written line L. A plane is a flat surface that extends without end in all directions. This is a picture of part of a plane, and it's showing that it goes in all directions. A plane has no thickness, and it has infinitely many lines and points on it. You can name it by a capital letter, like plane P, or by at least 3 points that don't lie on the same plane, like plane ABC. You would not call this plane A, because we're not naming it by a single point. If the P is out here without a point to it, or any other letter out here, they're naming the whole entire plane, and they're showing it by shading it. If you want to name it by points, you name it by 3 points. Okay. If you don't have all these written down, all these vocabulary words, you might want to write them down, because I'm about to change the screen to the next page to grab 3 more vocabulary words. You ready? 3 more: collinear, coplanar, and space. No, space is not the final frontier. This space is the set of all points in 3 dimensions. Collinear and coplanar, just like the word co-worker, that's somebody who does the same work that you do. Collinear are points on the same line. Same, co. Linear, see the word line in there? And coplanar, of course, are points or lines on the same plane. Like, for instance, we're going to talk about plane P. Points V, R, Q, and S all appear to be coplanar. Points R, Q, S are collinear on the same line. Points T and Q and N are collinear on the same line, that line that seems to go right through the plane. The dotted lines mean that that's the part that's underneath the plane that supposedly you're not supposed to be able to see. Lines RQ and AB appear to be coplanar on the same plane. Not necessarily parallel. Looks like eventually they would intersect out here somewhere. So, have you got these all down? I'm about to change screens again. 3 more vocabulary words: segment, ray, and opposite rays. A segment is a piece of line, like you chop the line off. It has 2 endpoints and includes all the points in between them, but none beyond them. So you would call this segment AB or segment BA, because it starts at one of the endpoints and goes to the other. Doesn't matter which direction you go, but that's all the farther you go. Notice how also this has a line above it without arrows. That means it's just a piece of line cut off at the ends. A ray is a part of a line, starts at one endpoint and continues on forever in one of the directions. You name it by its endpoint. You start with that, and any other point on the ray. You would name this ray, ray AB. Notice how where the point is A, that's the letter you start with, and it always goes left to right, ray AB. Even if the ray is going in the other direction, you start at the end point, give another point on the line, put an arrow down here, ray AB. Opposite rays are 2 rays that share the same endpoint and form a line. You name opposite rays by their shared endpoint and any other point on each ray. So if I had ray CA, from C to A and beyond, notice how it starts at C there, and even though this ray goes to the left, I'm actually writing my arrow to the right. CA, ray CA, and from C to B and beyond, ray CB. Got it? If you don't have these down, pause the video just a few seconds while you continue writing your vocab words, and then we're about to turn the page. Now we're going to do 4 postulates. A postulate is just an accepted statement of fact. You don't have to prove it. Everybody knows it's true. Here's the first one, postulate 1-1, and that says through any 2 points there is exactly one line. Pretty easy to understand that one. Postulate 1-2, if 2 distinct lines intersect, then they intersect at exactly one point, this one being point C. Even though that's the point where those 2 lines intersect, there's no dot there because you don't need one, because dots aren't really a dot. There is no spot, it's just the named location. It doesn't have a size. So this is line AE and line DB intersect at point C. Right, let's turn the page. Postulate 1-3 says, if 2 distinct planes intersect, then they intersect at exactly one line. Plane W intersects with plane plane R. Let's rename those. Let's call those plane WST, intersecting with plane RST at the line ST. I thought at first they were calling that plane W, but it looks like they call that a point. So we're going to say point W. Therefore, it's plane WST. You could say it's plane WTS. Doesn't matter. And this plane is obviously RTS or STR, named by those 3 points, with that line intersecting. Okay, so how is that useful to us? What if we had a question of what is the intersection of plane ADC and plane BFG? Well, plane ADC on this cube is defined by those 3 points right there. And it might be fairly easy to see that plane ADC is actually the top part of that box. Well, plane BFG is defined by points B, F, and G. That point, that point, that point. So maybe it's easy to see that that is actually the other side of the box. And once we shade those 2, it's fairly easy to see that those 2 planes intersect at exactly the line BC. We'll be doing questions like that, and let's switch now to the next screen. Postulate 1-4, the very last thing we need to do. Through any 3 non-collinear points, 1, 2, 3, there's exactly one plane, plane P. Points QRS. So how might that work out in a question? We're going to use this box down here. What plane contains points NPQ? I've dotted NP and Q with yellow already, and it might be fairly easy to see that they define the plane that slides right through the bottom of the box. Well, what if I said, what plane contains points J, M, and Q? J, M, and Q could be dotted with these red points. That one might be a little bit harder to see. I got a back point and a back point. Let's connect those 2 back points with a diagonal line. I've got a top point over here and a top point over here. Let's connect those with a line. So my plane is going to have parallel lines, right? What would be parallel to that one? Well, let's see. That would go through JP. Or, what would be parallel to that one? Well, it would go through there, so obviously I'm involving point P. So this might be easier to see if I shade it. And you see that it is actually the plane that slices diagonally through the center of that box. And those 2 planes intersect, by the way, in exactly line PQ. not K. By the way, it looks like K involves something down here, but it's really the point for this corner up here. You need to be real careful what corner you're calling what. Well, there you have it. That's the rules and postulates that we're going to be dealing with in this unit. See you in class.